Hello everyone, welcome to new class. Today's class is the continuation of string efficiency, that is the problems related to string efficiency. So let us do the problems. In a 33 kV overhead line, there are 3 units in the string of insulators. If the capacitance between each insulator pin and earth is 11% of self-capacitance of each insulator, find first one the distribution of voltage over 3 insulators and second one the string efficiency. So here the question is to find the voltage distribution of each insulators and also the string efficiency. First of all, draw the equivalent circuit of the 3 insulators. So this is the equivalent circuit for the string of insulators. Then V1, V2 and V3 are the 3 voltage distributions over these 3 insulators. Then C is the self capacitance and C1 is the shunt capacitance. Then corresponding currents are capital I1, I2 and I3 through the self capacitance and small I1, I2, I3 through the shunt capacitance. So here it is given that the capacitance between each insulator pin and earth is 11% of self capacitance. That is, capacitance between the insulator pin and earth is the shunt capacitance. So C1 is equal to 11% of C, that is self capacitance. That is C1 divided by C is equal to 11%, that is 0.11, and C1 divided by C is the fraction K. So K is equal to 0.11, and here so first we have to find the distribution of voltage over the 3 insulators, that is V1, V2, V3 we have to find. So for that we have to apply the Kirchhoff's current law at the junctions A, B. So before that it is given 33 kV overhead line. So this 33 kV overhead line means it is the line voltage. So here the string voltage is equal to phase voltage. So first of all we have to find the voltage across the string. So voltage across the string is equal to, it is the phase voltage, so we have to divide by root 3. So 33 divided by root 3 is equal to 19.05 kV. Now we have to apply the Kirchhoff's current law at each node. So applying KCL at node A. So we will get I2 is equal to I1 plus I1. And what is I2? I2 is equal to V2 into omega C, and that is equal to I1 is equal to V1 omega C1 plus capital I1 is V1 omega C. And here C1 is equal to K into C. So from here we can write C1 is equal to K into C. So here we will get V1 omega Kc plus V1 omega C. So after cancelling omega C, we will get V2 is equal to V1 into 1 plus K, and that is equal to, here K is 0.11. So 1.11 V1. So V2 is equal to 1.11 V1. So V2 is equal to 1.11 V1. Now we can apply the KCL at node B. So KCL at node B is I3 is equal to I2 plus capital I2. And what is this I2? This I2 is equal to voltage drop is V1 plus V2. So in the previous class we have discussed about these things. So if you didn't watch it, please go through it. So I2 is voltage across that capacitance is V1 plus V2 into omega into C1 plus capital I2 is equal to V2 into omega C. And here C1 is Kc. That is V1 plus V2 into omega Kc plus V2 omega C. So omega C, and here I3 is equal to V3 into omega C. So omega C get cancelled and we get V3 is equal to V1 plus V2 into K plus V2. That is here V2, that is this V2 is equal to 1.11 V1. So substitute that here. So V1 plus 1.11 V1 into K. K is 0.11 plus V2 is 1.11 V1. So here we will get V3 is equal to 1.342 V1. So V3 is equal to 1.342 V1. So here V3 1.342 V1. Now we can find the total voltage. So total voltage, that is voltage across the string. So voltage across the string is V. V is equal to V1 plus V2 plus V3. That is V is equal to V1 plus V2 is 1.11 V1 plus V3 is 1.342 V1, and that is equal to 3.452 V1, and here V is 19.05. So 19.05 kilovolt, and here we will get V1 as 19.05 divided by 3.452, and that is equal to 5.52 kilovolt. So V1 is 5.52 kilovolt. Now we can find the values of V2 and V3. So V2 is equal to 1.11 V1, 5.52, and that is equal to 6.13 kilovolt. Then V3 will be equal to 1.342 into V1, 5.52, and that is equal to 7.4 kilovolt. So the voltage across each string or disk is equal to V1 5.52, V2 6.13, then V3 7.4 kilovolt. So from here we can see that the maximum voltage is across the string which is nearest to the conductor. So V3 is equal to 7.4 kilovolt. Now next question is to find the string efficiency. So string efficiency is equal to the voltage across the string divided by number of disk into voltage drop across the disk which is nearest to the conductor into 100. And what is V? V is, so this is V, 19.05, then divided by N, number of disk is 3 into V3. V3 is 7.4 kilovolt into 100, and that is equal to 85.8 percentage. So this is the string efficiency. So in this way we are doing the problems related to the string efficiency. Let us do another problem. A three-phase transmission line is being supported by three disc insulators. The potentials across top unit, that is nearest to the tower, and middle unit are 8 kV and 11 kV respectively. Calculate the ratio of capacitance between the pin and earth to the self capacitance of each unit, then the line voltage and string efficiency. So in the question, we have to find the ratio of capacitance between pin and earth to the self capacitance, that is C1 to C we have to find, that is K we have to find. Then next is line voltage and string efficiency. So the given parameters are the voltage across top unit and middle unit, that is top unit is V1. V1 is given 8 kV and middle unit, that is V2. V2 is given as 11 kV. So how will you find the value of K? So applying KCL at A. So KCL at node A. So I2 will be equal to I1 plus capital I1. So I2 is V2 into omega C, that is equal to I1 is V1 omega C1 plus capital I1 V1 omega C. And here C1 is equal to, so from here we get C1 is equal to K into C. So C1 is equal to K into C, that is V1 omega Kc plus V1 omega C. So omega C get cancelled. So we will get V2 is equal to V1 into K plus V1. So from here we can find the value of K. K is equal to V2 minus V1 then divided by V1, and that is equal to V2 is 11 minus 8 divided by 8, and that is equal to 0.375. So K is equal to 0.375. Now the next question is to find the line voltage and string efficiency. So to find the line voltage, we have to find the voltage across the string, that is V1 plus V2 plus V3. So for that we have to find the value of V3. So next we have to apply the KCL at node B. So here K is equal to 0.375. Now applying KCL at node B, so we will get I3 is equal to I2 plus capital I2. So I3 is V3 into omega C equal to I2 is V1 plus V2 into omega into C1. C1 is K into C plus I2 is V2 into omega C. So here omega C get cancelled. So V3 is equal to here V1 plus V2 into K plus V2. So V1, V2 and K we know. So V1 is 8 plus 11 into K. K is 0.375 plus V2 is 11. And we will get 18.12 kilovolt. Now we can find the total voltage, that is voltage across the string. So voltage across the string is equal to V. V is equal to V1 plus V2 plus V3, and that is equal to V1 is 8 plus 11 plus 18.12. And that is equal to 37.12 kilovolt. So this is the voltage across the string, and we have to find the line voltage. So what is line voltage? So line voltage is root 3 times this phase voltage. Therefore the line voltage is equal to root 3 times 37.12 kilovolt, and we will get 64.28 kilovolt. Next question is to find the string efficiency. So string efficiency is equal to total voltage divided by number of disc into V3 into 100, and total voltage is here. So here total voltage is the voltage across the string, and that is in phase voltage, that is the phase voltage, that is 37.12 divided by 3 into V3. V3 is 18.12, and we will get it as 68.28 percentage. So into 100. So this is the string efficiency. So in this way we are doing the problems related to the string efficiency. So in the next class we will discuss more problems related to this string efficiency. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.